welcome to Quadratics 5.2, Pure Imaginary Numbers. Okay, so we're going to continue from the last lesson where 5.1 introduced to you the situation where imaginary units come into a problem, and I'm going to show you guys how that happens. Yeah, so we're going to do actual problems that are going to have imaginary numbers appear in them. Okay, so let's get to our first problem. And the examples there, you can look at them too if you want to, yeah, or just watch the video. Either way is fine. Okay, so we're going to introduce imaginary numbers coming into problems in our computation. Okay, so our first problem we're going to see square root negative 81. Yeah, and basically because we see a negative sign in the square root symbol, that's pretty much your sign that there's going to be an imaginary number that appears in your problem. Okay, so we're going to remember our conversion, which was the negative sign turns into II. Yeah, and then some kids, they usually ask, I don't see a negative 1. Yeah, so a negative and a negative 1, they're basically the same thing. So you don't necessarily have to see the negative 1. So as long as you see that negative sign, then that's pretty much your green light to go. Okay, so we're going to turn the negative sign into II. We're going to turn the 81 into 9 times 9. So I hope you guys remember your perfect squares. And if you do, then that's good. Then we're going to circle things that match. And because the i's match and the 9's match, they got circled. They're going to go outside. And your answer is 9i. Okay? Okay, letter B. So same scenario, negative sign in your square root symbol, so that's going to turn into II. The 5 we're going to try to break up, but it's not going to work. Nothing's going to happen. It's already a prime number, so it's going to stay as is. Okay? We're going to circle the i's because they match. Not going to circle the 5's because they don't match. And we're going to get I root 5. Okay? Alright, let's look at the next one. Okay, so negative 54 in the square root symbol, so same thing. Okay, so the negative sign turns into II. The 54, that's not a perfect square. If you don't know how to factor tree 54, I can refresh your memory right now. Right, so 54 goes on the top of the tree. Then you write two numbers that make 54 right beneath it, so that would be 6 times 9. Then you break up the 6 even more, so that's 2 times 3. And you break up the 9 as 3 times 3. Okay, so all these numbers, they create 54. So we're going to also add them into the square root symbol. So 2 times 3 times 3 times 3. Okay, we're still going to get the red pen out. We're going to circle things that match. So the i's match and the 3's match. Okay, so let's see what jumps outside. So 3i jumps outside. The 2 and the 3, they didn't get circled, they didn't have partners, therefore they're just going to be put back together again to make a 6, and there's that answer. Okay. Letter D, same pretty much concept that we just did in the previous 3 problems. The only difference is they added a negative sign on the outside, and they also added in or threw in a divide by 25. Is that going to change what we do? No, it's not going to change a single thing. We're just going to ignore the negative sign and the 25 for now. And we're just going to concentrate on negative 75. So this is going to look exactly like the problems we just came from. Okay, so we're going to break apart this negative 75. So the negative sign turns into II. And if you need to use factor tree to break apart 75, that's fine. If you don't need to, because you know your math pretty well now, you know that 75 is 3 times 5 times 5. Okay, now we're going to get the red pen out because it's going to circle things that match. So the i's get circled. And the 5's get circled. Okay, so when they come outside, they're going to make 5i. And they're going to leave behind the 3 inside the square root symbol. Then we're going to unignore the negative sign and divide by 25. And we're going to put that back into play. And we're going to see what that does. So basically what it does is the 5 and the 25, they're in the fraction. And hopefully you remember from your elementary school days that whenever you have a fraction that can be simplified, it's your duty to simplify the fraction. And 5 and 25, they're both on the outside. Right? You don't want to simplify anything ever on the inside, like the 3 with the 25. I know 3 and 25 don't simplify anyway, but you can never simplify numbers that are inside the square root with numbers that are outside the square root. That's a big no-no, so don't do that. Okay, so the 5 that just got circled, that just got put on the outside, is now able to simplify with the 25 that's on the bottom. It couldn't before. You know what a lot of kids do when they do this problem? They see 75, they see 25, and they simplify it right then and there. So they put negative 3 and 1 on the bottom. You cannot do that. Okay, that's a big no-no, so please don't do that. All right, when you simplify, you can only simplify numbers that are in the same location. So this 25 is outside the square root, 75 is inside the square root. So they are in a different location. So they're not allowed to interact in that sense, as far as simplifying is concerned. Once I circled the 5 and I brought it outside, now the 5 is on the outside and is able to simplify with the 25 that's also on the outside. So when that happens, we can divide by a common number, which is 5. So we get 1i up top, square root 3 over 5 on the bottom. Okay, and like I said, the big mistake that kids always make is they see a 75, they see a 25, and they call that 75 negative 3 instead, because they divide by 25. You cannot do that. Yeah? And I know you're going to do it, and you're going to say, you didn't tell me that. I'm going to say, watch the video again. I say it a couple of times in the video. Don't forget it. Okay? All right, moving on. Okay, so we're going to see what's next, and now we're going to start incorporating the problems we did in A, B, and C, and D into a bigger problem. So we're going to do twice the simplification process of numbers inside square roots. So this is hopefully where you're going to have perfect squares a little bit better in your brain, so you can start skipping steps, especially the factor tree. Factor tree is good, but it takes up time and space on your paper. So if you can do this in your head, then it helps out a lot. Okay, so we're going to simplify negative 25. We're going to circle the i's. We're going to circle the 5's, and it's going to become 5i. Yeah, so we're just going to deal with these things one at a time. We're not going to do it all at once, because that's going to get confusing. Okay, then we're going to deal with the negative 36. So square root of, negative sign turns into I. 36 turns into 6 times 6. Okay, then we're going to get the red pen out. We're going to circle things that match. And the I and the 6, they both match. They're going to jump outside as positive 6i. Okay, and when you get to this stage, you're going to say to yourself, what do I do now? And you're going to just tell yourself, ooh, this looks like it's a like terms situation, where I looks like a letter, and we're going to treat it as if it's a letter in this situation. Okay, I is not really a letter, it's a number, right? But we're going to use the rules that we know about like terms, that if they possess the exact same, I guess, things at the end of the number, which in this case would be an I, then they're like terms. So because they both have regular plain old I after each of their numbers, so 5i, 6i, we can combine them to make 11i as our final answer. Okay, so we're going to just do like terms at this stage. All right, okay, so let's look at B. So letter B, we got negative 81. That sounds familiar. I think we did that in letter A. We're just going to go through it as if we didn't do it ever before. Yeah, so 9 times 9. And why did that big line get drawn where my hand is? So let's erase that big line because it's not supposed to be there. Okay, all right, so let's circle things that match. The i's match, the 9's match, and when they jump outside, they're going to make 9i. Okay, then we're going to deal with the second part. So negative 2, yeah, that's on the outside already. And then square root of, negative is going to turn into I. And the 64 is going to turn into 8 times 8. Yeah, so I know my perfect squares. Hopefully you do too. So when I circle them, the i's get circled, the 8's get circled. And here's where you want to be very careful. Okay, usually when I get kids that make a mistake, here's what they do. They just write 8i. And they forget about the 2 that's already on the outside. Yeah, because that's what we've been doing in the previous problems. We've just been writing the number that gets circled on the outside. We never had a number outside to begin with. Yeah, so here's where their first mistake is going to be. They just write negative 8i, just like this. But that's not correct, because there's a 2 also on the outside. So you got to make sure you put that 2 there. And the interaction that happens between the 2 and the 8i is multiplication. Yeah, so when the 8i jumps outside, it's going to join the negative 2 via multiplication, and we're going to get 9i minus 16i. Yeah, and these guys are like terms, and when we combine them together, we get negative 7i. And there you go. Okay. All right, moving on. Okay, so now we're going to start multiplying with imaginary numbers. Okay, so hopefully you remember from a previous lesson last quarter where I told you that answers have parts to them. Every answer is going to have a sign, every answer is going to have a number, and every answer is going to have some kind of a letter part. Okay, so we're going to treat the eyes. I know it's a number, but we're just going to treat them like it's a letter because it looks like a letter, so we'll just treat it as if it's a letter. Okay, so we're going to look for our sign first. So a positive 3 times a negative 6. So a positive times a negative, guarantee that's a negative. Okay, so I know I have a negative answer. Yeah, then I'm going to look at my numbers, so 3 and 6. And what does that make when I multiply them? 18. Okay, and I got I times I, that's my letters. Yeah, and remember I told you guys in the last, well, not the last lesson, but in a previous lesson that when you multiply letters, yeah, they're gonna have a power appear, and the power that appears basically is the amount of letters that you have. So since it's I times I, that's 2 I's that I count, so my letter or variable part of my answer will be I squared. So when you multiply letters, you just count how many you have, and that's going to be your power or exponent. Okay, so this is where it's going to get tricky. Yeah, normally we just call it a day. We'd end it right here, but because this is not a variable, this is a number, an imaginary number, we need to remember our conversion, right? That's why I wrote it up top here. I squared equals -1. Okay, so I see an I squared right here. So here's what I need to do. I need to do this conversion. I need to turn the I squared into -1. And then kids always ask, do I have to do that? And I say, yes, you have to do that. That's a law. That's required. That's like simplifying fractions, right? Kids, you always ask, oh, do I have to simplify the fraction? And your teachers always say, yes, you do. Okay, so kids always ask me, do I have to turn that I squared into -1 and continue on? And I go, yes, you do. Okay, so I got -18. That's going to stay the same. But the I squared is going to turn into a -1. And the interaction between -18 and -1 needs to be multiplication. And it needs to be multiplication because that's how -18 and I squared are connected in the first place. -18 and I squared are connected by multiplication. So when I turn that into a -1, that bond, that connection of multiplication still needs to exist. Okay, so then I go -18 times -1 and I get +18. And there's your problem. Okay, so be very careful with these. Yeah, you got to remember that last step. Okay, so letter D. So positive times a positive is a positive answer. 8 times 7 is 56. I times I squared. Okay, so this part should be pretty straightforward. Okay, the next step you got to remember is this. Yeah, you're bound by law. It is required of you to turn this I squared into a -1. This is not an option. You need to do this. If you don't do this, then you're not going to get full credit. Okay, so the 56, the positive 56 stays the same. The I squared turns into -1. It's going to connect to the 56 via multiplication, and it's going to turn your final answer into -56. Okay, so be careful about that. All right. Let's go to the next one. Okay, so now it's going to start getting trickier. So I'm going to give you more conversions. Yeah, it's like when you have money, right? If you need to make 25 cents, yeah, you can get a quarter out, or you could get 25 pennies out, or you could get 2 dimes and a nickel, or you could get 1 dime and 3 nickels, or you can get 5 nickels, right? There's lots of ways to do conversions. Yeah, and these I numbers, this brand new thing that pretty much just came into your life, they also have different conversions also. So here they are. I to the first power is known as positive I. I to the second power is known as -1. I to the third power is known as -I, and I to the fourth power is known as +1. Okay, so these are your conversions, right? So when you see these types of i's left in your problem, you can replace them with these conversions instead. Yeah, so if I see an I to the fourth, I can replace it with +1. If I see an I squared, you already know, you can replace it with -1. Okay, so that's what we're going to do in these next 6 problems. We're going to simplify what they give us. Okay, so they start us off with I to the third. So based on our conversion, we know it's called -I. Yeah, and if you want to know how they got that, they give you a little hint, right? They tell you that I to the third is known as I squared times I to the first. I squared is known as -1. I to the first power is known as I. So -1 times I is -I. Okay, so that's how they do that. Okay, I to the fifth. Okay, so we're gonna use that hint because does our chart have an I to the 5th conversion? No, it only goes up to I to the 4th power. So I to the 5th, we're going to use their hint is a result of I to the 4th, which we're going to replace with positive 1, times I to the 1st, which is just positive I. Yeah. So when I go positive 1 times I get positive I. Okay. Okay, I to the 7th, we're going to use their hint again. So it says I to the 7th is known as I to the 4th times I to the 3rd. I to the 4th is going to be my positive 1. I to the 3rd, based on my conversion chart up there, it's negative I. So positive 1 times negative I is negative I. Okay? All right, I to the 4th, we're just going to use our conversion. They give us a hint as far as how that comes about, right? But we know our conversion, or hopefully you know it. Yeah, hopefully at the end of this lesson, you know your conversion chart pretty well. Yeah, it might take some getting used to, but yeah, you'll get there as long as you practice, right? If it's something that you use a lot, then it'll not be that bad. Okay, so I to the 6th is known as I to the 4th, which is positive 1, times I squared, which is negative 1. Yeah, so all I'm doing is I'm just replacing I to the 4th with positive 1 based on my conversion chart up there on the top. I'm replacing I squared with negative 1 based on my conversion chart up on the top. And then I'm going to multiply these numbers together and I get negative 1. Okay? So last one, I to the 8th. So I to the 8th is known as I to the 4th times I to the 4th. So that's basically 1 times 1. And what is 1 times 1? 1. Okay, so there you go. Okay, so now let's get to some bigger powers. Okay, so this is going to be kind of humbug because I'm going to write a lot so that you guys can see the pattern. Yeah, so I to the 33rd power. Okay, so we're going to break that up into as many I to the 4ths that we can. Yeah, and the reason why you want to break it into I to the 4th power is because that turns into the easiest number to work with. Right, so if you remember, I to the 4th turns into a 1. Okay, so I to the 4th. So that's 4 so far. I to the 4th, that's 8 so far. I to the 4th, that's 12. I to the 4th, that's 16. I to the 4th, that's 20. I to the 4th, that's 24. Dude, I was going to write 28 because that's the number I'm thinking about, but I'm supposed to write a 4. Okay, so I to the 4th. Oh, that's not the marker I wanted. I wanted a pen, not a highlighter. Okay, so I to the 4th. Is that 28? 1, 2, 3, 4, 5, 6, 7. Yeah. I to the 4th, that's 32. And I have 33, so I have to put I to the 1st power. Okay, so let's count it up. 4, 8, 12, 16, 20, 24, 28, 32, 33. So all these I to the 4ths are going to get replaced with a 1. 3, 4, 5, 6, 7, 8, and the I in the end. Okay, so here's where kids usually make a really big mistake. Okay, watch what they do as a mistake, and let's see if you can tell me why they make this mistake. When they get their answer to this problem, here's what they write. They write 8i. Why do you think they write 8i? Because a lot of them, they don't put the parentheses. And because they don't put the parentheses and they just put a bunch of 1s, they forget that these 1s are multiplied to each other, and they add them instead, and they get 8i as a result. Okay, it happens every year. Yeah. So if it happens to you, don't worry. You're not in a small group of kids that make this careless mistake. There are lots of kids, tons of kids make this mistake. So don't worry. Just don't keep on doing it. Yeah. Once you do it, then remember that this was something I warned you about, and just say, yeah, I'm not going to do this anymore because Ishikawa said to not do it, and I did it. So I did it once. Hopefully, I learned my lesson. Okay. So we're going to erase the 8, and we're going to put what all of these numbers multiply to become, and it's a 1. Do we need to put the 1 there? No. You can just write I if you want. Yeah, but I put the 1 there because it reminds me that I took into account what all those 1s do. Okay? All right, so let's look at I to the 30th. Okay, so like I said, this is going to take a lot of writing. So we're going to write I to the 4th a lot of times. How many is that? 4, 8, 12, 16, 20, 24, 28, and we have 30, so I can't go 4 more because that would be too much, so I gotta go I squared. Okay, so 4, 8, 12, 16, 20, 24, 28, 29, 30. Okay, so I'm going to replace all these I to the 4th powers with a 1, 4, 5, 6, 7, and then negative 1. Okay, so I replaced all the I to the 4ths with a 1, and when I multiply everything together, I get negative 1. There you go. Okay. All right, so next problem. I to the 15. So let's see, how many I to the 4ths make a I to the 15? So we got 4 so far, we got 8, we got 12, and 3 more, that makes 15. Okay, so that's going to go 1 times 1 times 1, and I to the 3rd is negative I. So let's multiply everybody together, and I get negative 1I. Yeah. Okay, last one. Oh my goodness. I to the 80th power. We really need to change this problem because I don't really want to write I to the 4th that many times, but I guess I will. Yeah. So let's just do it. Let's get it over with. So I to the 4th. 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 60 so far, yeah? 1, 2, 3, 4, 5. Okay, all right, so that's 80 I's. Oh my goodness, I don't believe I really did that. Okay, so all of these I to the 4th powers are going to get replaced with 1s. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, and you got to remember, all of these 1s are multiplied to each other. Yeah, because a lot of kids are going to say, oh yeah, my answer is 20. No, your answer is not 20. Yeah, what do all these 1s make when they multiply to each other? They make a 1. And there you go. Okay? All right, let's see. What else do we have? I think it's the homework as my next slide. So, I believe this video is done. Good luck on this assignment. And I'm pretty sure we didn't give you any problems that have I to the 80th power or not. We're not going to give you something irritating like that. Yeah. If we did, we'll change it next year. But yeah, you won't be around anyway, though. Okay, all right. Good luck on this assignment, and I'll see you later on. Bye-bye.